Maybe we try it now. Can you hear us now? Perfect. Okay. So again, welcome to this webinar.
Yes, welcome.
My name is Robin.
I'm Ignatius.
And we're going to be the host for this webinar again. It's the webinar Netfabb Basics number 2. So today we're going to cover the workflows, especially because Netfabb is built out of workflows if you're using our engine. So if you look at the agenda today, we have the workflows itself, and then we're going to have a closer look what's in the workflow, so arrangement, modification, and so on. In the end, we will have a short look at the automated workflow to see what's the benefits and how this is working.
Yeah.
So without further time to lose, let's continue with the next step.
Right. So thank you, Robin. As Robin mentioned, Netfabb is comprised of different workflows depending on what type of model or indication you are working with. So let's just quickly go and have a look at that in Netfabb. So on the right hand side of Netfabb we have the menu item or the communication panel, or
the user interface of our engine.
That makes it much better. So the purpose of the workflow is to make it a lot easier for the users to handle Netfabb, and also it encourages them to follow a specific pattern so that they have more predictable prints, and it also allows for less user errors as they're basically being guided through that whole process. Okay, so let's go and have a look in Netfabb what that looks like. So I'm just going to transition over into Netfabb. So as we were mentioning, on the right hand side we have that user interface. Right at the top we're looking at the workflows drop down menu. So depending on what indication you are working with, for example, if we're just looking at model and stump, we will see that after it loads this interface there are less work steps as it's already predetermined. So each workflow consists of work steps. Depending on which workflow you select will determine which work steps will be applicable. So in the workflow, that's where you have that option. We go just into the manual so that we can work through all the work steps manually, and then, like Robin said, at the end we'll do an automated version of this. So initially we can load parts, so let's go and do that right now in the parts tab. I'm just going to load a simple box. It's a good sample for this demonstration.
Yes.
So I want to have more than one, so I'm just going to duplicate to make sure that I have adequate amounts. So when I import my parts, it might be outside of my build area, something similar to this. So what I'm going to do is I'm going to highlight all my parts. I'm going to basically the second work step. If you're ignoring the parts or loading of parts, we're going to arrange the parts, which we call nesting. So there's a couple of things here to take note, but by default these settings are very reliable. Later on, when we have a bit more in-depth coverage, then we can talk a bit more about the details of it. But the default settings are fine, so we're just going to perform that. Thank you, Robin.
Welcome.
So now that we have nested it, we just want to position it in the middle of our build area. So again, I'm selecting the parts. I go into the next work step, and then I can center it. And as you can see, that has centered nicely in the middle. The only thing to note now is on the left-hand side of the work steps, there's a green tick that becomes available or becomes visible. This helps the user identify which steps they have completed so that they don't do retakes or they don't go back on their own progress. Okay, so these are the first and just the arrangement oriented processes within the workflow. We will now progress on to the next step, unless somebody had any questions as of yet.
Not yet. Maybe we can just mention, because we've got it on the slide,
yes.
the manual adjustment. So if we need to rotate parts, which maybe will occur sometimes depending on the output of the design software.
Yes, yes. So say for instance, this one part here, was not quite in the right space, or
Yeah.
something that you wanted actually in the stump area, you can highlight it and just move it around. And if you need to rotate it, you see the blue will be in the flat angle, the green is rotating across the Y, and I'll just Control Z that. And the blue rotates it along the other side. And if you go into a different perspective, you can also see there's a red
Yeah, you should show Netfabb.
yes, of course, good point. My apologies. I was just referring to this one cube here. Let's highlight it nice and clean. So we have this interface. You see the blue circle that becomes visible. This allows me to rotate it according to the perspective that I'm looking at. If we change that perspective, we see a green circle become visible, and another perspective, the red. And it's as simple as that. You can manually rotate this, or you can just type in here what angle you want to change it by. Please note that when you type 90, it's adding 90 to its original position. It's not taking it to a 90 degree. This can be done more manual oriented. All right. So if there weren't any questions as of yet, then we can progress onto the modification.
So regarding the modification, there is at the moment just the modification for hollowing the parts. Regarding hollowing parts, of course, the first question you ask yourself, or the customer may ask you, is why should I hollow my parts? So of course, the parts have not to be hollowed, so they mustn't hollow them. But to hollow it, there's a lot of benefits. For example, we just walk through them. Less material consumption. Solid models, more material. Hollow models, less material. The same thing, if you got hollow models and less material consumption, you also got a smaller surface which is printed. Means this is less separation force. So therefore the Teflon foil of the reservoir will have got less stress, and therefore you can get a longer lifetime of the reservoir. Additionally, there's a possibility that you will reduce the printing time as well, depending on the model and how much models maybe at the same time you are printing. So in general, you can say what we are doing, we are reducing the overall costs of the print job, or of the time we are taking for the print job, which is kind of a good benefit. So how to hollow in Netfabb, or where to hollow, let's just quickly continue. So I will transition to Netfabb. I will just delete the cubes for now, and I will load a new part. You will also see if I load a new part, the green check marks will become again in normal state, so the 3 dots, because I didn't execute something for my new part. So I will just load this one. And now I will just click on the hollow parts section, so, or the work step. You can see in here, there's a slider which you can just select the quality, speed or standard setting for the calculation. Important to understand, Netfabb calculation is based on triangles. So all shapes, all bodies, all STL files in there are built out of small little triangles. So this means for the calculation, speed, triangles are a little bit bigger, quality is therefore a little bit less than if you use the quality setting. In the quality setting, triangles are smaller. Of course, calculation time will go up if you use the quality setting. Next one is the wall thickness. It's now set to 3 millimeters. I will just keep it. This is just the thickness when you hollow it, what stays at the end. And you got the check mark for smoothen the inner space. So smoothen inner space after hollowing, it's inside of the model, not the surface you can see, because it's inside and not the surface, which is important. So you can smooth it, you can not smooth it. It's all about triangles again.
Yes.
When you smoothen it, more triangles on the inside to get a little bit better surface. Next check mark is the open bottom. So open bottom means you're cutting the model open on the bottom. We are using different calculations, so your model won't have a shorter height or something. It's just calculated, so we are opening the bottom in order to remove the fluid or the not solid material after printing out of the model.
Yeah.
So in order to get then again something in between, maybe to add more strength, you can use the add grid. So we will add a grid according to the settings over here. I will tell you about the settings later when we go to the base plate settings, because they are the same. One option which is not available later on in the base grid is the lift by X amount of millimeters. Nothing to use for you at the moment, it's just for industrial purpose, nothing to worry about at the moment. So just to see what's going to happen, I will set it on speed and just wait until it's hollowed. So, of course, we also got some recommendations for the hollowing setup. Please be aware, everything we are recommending now in this webinar is just general recommendation. There's of course a lot of difference in between which material are you printing with, which design are you printing with, what's the purpose of the usage after the printing, and therefore it's just general recommendation where you can at least orient a little bit on there. So now the thing is hollowed. We just have a quick look that we can see it's really hollowed and nothing is cheated. So let's have a look. You can see I used the clip planes. This is going to be something we will also maybe show you later in a following webinar, or eventually you know about this. So just that you see, this is now the hollowed part, and that's all the process we needed to do, just clicking this button and perform. Regarding the recommendations, most likely, like I said, we use speed, settings, surface on the inside, doesn't matter that much. The wall thickness, we set between 2 and 3 millimeters. There should be everything okay, depending on what the post or what the action is you need afterwards. Yeah. The smoothen inner space, we now set it for yes in a check mark, and most likely we use it because it's not that much time consuming, so you can still smoothen the inner space. And we use the open bottom and use the base plate with the preset value. So we're not changing the values, we keep it, that's a recommendation.
Correct.
Okay, so I think that's it for now for the modification. I've seen that there's some questions in the chat. So Antonio's asking once, can you remove that option from the menu? I think you're talking about the hollowing part option. So the hollowing part option, so the work step we see in Netfabb on the right side, so this one is, for example, available in the manual work step. As you now just do this one manually, you can select which one you want to execute. Yes. Of course, you can say, well, I have already a hollowed part by another software. There are softwares, for example, CARES, which are just designing the model already hollow. So you don't need to hollow it. So you can just click the next step. It doesn't matter. You don't have to push all work steps in order to create a build. Yes. No issue. You can do that. Especially, for example, in CARES, you can also hollow it in a way that, for example, no supports are needed. Yeah. Sometimes, depending on the design and which software you're using, it can be that hollow parts need some supports, which we'll have a look at soon. Ignatius will then explain to you when you need these supports. But for example, in CARES, you won't have to use it. So next question from Antonio. So can raw unprocessed STLs be used to bypass the model builder software? I assume you're talking about scan files. That's for me raw STLs which are unprocessed. Is that correct, Antonio? Okay, so you have to understand Netfabb is a computer-aided manufacturing software and not a designing software. Yeah. So most likely Netfabb is used to process already designed projects into a format which the printer can read. So if you're now trying to get a scan in there, the scan is not a fully shaped body, it's just a surface most likely, and the model builders, they can make a body out of it. Yeah. So Netfabb is not really prepared to use files like that.
Short answer, no. But yes, there are some modification functionality within Netfabb, but this is not something that we're going to cover right
It's
now.
not a design.
Yes, it's
software.
not designed by like that, yeah.
Okay,
Okay.
so I think you can continue.
All right. So let's continue on to the supports that are available in Netfabb. And what we're going to cover here is some general guidelines or advice that we have when to use supports, why we want to have supports, and how can you look out or maybe spot where you might need supports before you actually send that job to the printer. Okay, so there's 4 different areas or categories that we look at before we actually send that job to the printer, and these are the critical area, angle, the overlapping and overhanging areas, surface area in contact with the build platform, and lastly are the islands. Now, we will get to the islands. It's a bit tricky to understand just by naming it like that. But when we look at the work steps inside Netfabb, we can see that on the right hand side you can select your part and then go through the add support processes. Now, this is what we will look at right at the end, okay? Well, after this.
General recommendation.
That's right. Sorry. Okay, so the first one was critical angle, and this should be pretty straightforward. We can see that there's a green angle in the plus 45 degree range. Anything, if it's got a slant that's less than 45 degrees, then there would be concern whether or not it will build successfully or reliably. And then it's sometimes best to design it in such a way that no supports are needed, but understandably not all designs have that freedom, so to speak. And in this instance, if you can see that there's an overhang that's less than 45 degrees, then ultimately there would by default be supports needed. The next one is the overhang. So the green section of this model, we can pretty comfortably say that no supports would be needed. But then again, this all depends on the type of material that you're printing with, because the materials have such a range of characteristics that it's very difficult to say that you can print the same support structure on every single design. It just doesn't work like that. So we have the green sections, which fairly comfortable, it's going to print. The orange section, yes, most likely will have to use supports there, and the red, most definitely. Otherwise, you will have a failed print. The third topic is this surface area. Now, we're not saying that you have to cut the model in such a way that it has a majority of surface area in regards to that model. We're just talking about the amount of contact your model is making with a build platform during the printing process. So when we look at the green ball here, we see that the full surface area of halfway through that ball is in contact with the build platform. So there's no way that we would think that this would fail. But when we look at the sphere to its left, we can see, okay, we would believe that every layer will build off of the first layer, but the amount of surface area later on in that model is so great that the contact between the reservoir and that model might be stronger than what that model has on the build platform. So in this instance, we'd probably suggest to lower that a little bit, or to use supports that will make sure that the model is going to hold onto the build platform, because ultimately, if it's not holding onto the build platform, you're printing it in the reservoir, okay? And then the fourth one are the islands. Now this one is a bit more tricky to spot because it's generally in hidden locations inside models when you've hollowed it. And like Robin was mentioning about the CARE software, where there's designer software that compensates for this, but not all designing software works like this. Say for instance, you have a model and under a big molar, there is a low-hanging surface inside the model, which will look something like this. So you go from layer 19, where you see the wall of the model, and then all of a sudden the wall has this center part to it seemingly out of nowhere. This particular spot is known as an island. And these you can verify in the preview window. So after you've positioned, you've created the job, you sliced it, then you have this preview window where you can go through the layers, especially with new designs, to go and verify that each layer is building off of a previous layer to prevent any unforeseen failures that might happen. Okay. Let's go and look in Netfabb real quick, and we'll quickly show you how that would work. So I'm going to get rid of this part that Robin has in here, and I'm going to import real quick a helix. A helix works really well because there's lots of angles. Yes, there's lots of angles, and it's an interesting shape to work with. Let's just move it up a little bit so everyone can see. So in this instance, I'm going to leave it in this position, but I'm going to use the automated support scripts that we have. So what I have is I've selected my part. I can go and select supports or add supports in my work steps. And then I am given this, yes, my apology, no, that's right.
Let's just switch to the slide so they can see.
Yes, yes. We have some options here. Import external support, so sometimes you can create your supports in a third-party software. Creating for or import for multiple parts. We can create custom supports, which we'll cover in a future webinar. But what we would recommend is to use integrated supports that will run automatically on that part. And then you have a drop-down list of specific scripts or support scripts that will be applicable for specific indications. For this instance, I will just use a quick support demonstration, and the last option here is to lift the parts off of the build platform. Now, again, we'll go into further detail about this, but a support structure is made out of separate sections, and the best support needs a bit of space to properly generate. So we say roughly 3 mil as a minimum should be sufficient for the support to properly form, as to not to interfere with the design of your model. So I go and perform this now, and we'll just wait for that to load. And here we can see that the supports have been carried out on this helix. It's quite intense, but this is what it comes down to, is the settings in the support scripts will depict what happens or how it will be placed. Okay, so that's very important though to note that before you run the script, you need to be happy with how it's positioned, because if I go and reposition this, it's not going to readjust the supports. Okay, so position the model first, run through the script, and then it will be fine as it is. Okay, so I'll just control this. I'm assuming there's
yeah, let's go for the recommendation, as you said already.
Yes, okay.
So if you just get the next slide, I think that's the recommendations.
Yes, well, it's difficult to give recommendations regarding this, but what we would say is use the scripts in the automated workflow. If that script does not work for your particular model or in your particular instance, please verify that you have the current engine, rapidshape engine running on Netfabb. And if this is still current and you're still having problems, please contact rapidshape and we will get in contact with you to better understand why this is happening and to try and resolve this. But ultimately we're working forward because, again, it's very difficult to make one script that will fit to 100% of designs. So we try and cover as many as we can with as few as we can, ultimately.
Yeah. So you got some questions in the chat now.
Yes.
So the first question is, okay, it's about hearing aid shell support from Jan. He says the shells are printing with support on the shell edge, same height. Do we have the support setting in Netfabb?
Yeah, the shells are printing with support on the shell edge. Yes. At the same height.
So I assume, Young, you are asking for because yes, of course, he's most likely dental at the moment. So you're thinking about a surface area which is flat or parallel to the platform directly, and then adding supports on this area. That's how I understood. So, and yes, of course, you can add supports there. There is no support script for it yet, so there's a little bit of playing around, and this is more advanced to set up a script for this.
Yes.
So, but possibility, yes.
Yeah, but we will go into more depth of support script generation in a future webinar, so that everyone can understand how they can create their own scripts for their own designs. Okay.
So one more question is from Wesley. If the vertical length is limited for support, well,
yes.
He said for the model type resin, for example.
Yes. So if there's a limit on the height, then, for instance, in this demonstration, we can see that it would probably place some more supports in this vacant space here, but because of the height restriction on this script, it just cancels it out. So this all depends on what type of script you are running automatically. If there is a restriction on the height, then we would probably suggest that you create a custom support script on such a high part, but by default, I'm not sure why you'd want it so tall.
So you always have to bear in mind, if you make long supports,
yes,
they're not as stable as before anymore. Maybe you have to make them real thick in order to carry this weight over the long distance.
Correct, yes, yes. So it is, and like we said, it is quite general, our advice here, because all materials behave so differently and all designs are so unique. This is just a general overview of what we would recommend, and then ultimately with future webinars.
Yeah, I think
cover
a little bit more covering a few webinars.
Yeah.
Okay, so Antonio is now asking also if Netfabb can warn users of the existing of iLinks.
Currently, this is not implemented in Netfabb. That's why the preview window is presented. Currently, the only warnings is if you're outside of the building area. Okay, but it's all user related. That they need to verify this, especially with new designs. Yes.
Okay, so I think that's the questions for now. So let's just continue with the next step. In Netfabb, you can already see the next button in here after removing supports would be the create base plate. In order to create a base plate, you need to know why to create a base plate. As mentioned in the hollowing, you need it, for example, to strengthen hollowed parts, as well as to connect supports and or badges. If the supports are really thin, they can, for example, fall into one of these holes of the platform you know about, and if you got a grid underneath it, it will just prevent the support from being not printed, as it's not connected to the platform. To connect, for example, badges, it's also used, as you can then separate the badges. Maybe you print one part of the model with a stump on this area and the other thing on this area, but on the same printer. You can get just on this badge one grid underneath it, and on the other badge another grid, so you can separate it easily from the platform, and later on in the post-processing nothing will get something missed, or you won't mix the parts up. And the last one is, of course, with the build platform, it's easier to remove it with the build plate. It's easier to remove it from the base platform, because only the supports, yes, it's gonna work depending on the support style, but you're gonna have a hard time if the supports are breaking on the bottom and you can't remove them properly. Then you have to remove the supports one by one.
Individually, yeah. And that's never fun.
No, not really. So, how to create a base plate? So sometimes it's called base plate, sometimes it's called base grid. We are now calling it base grid in Netfabb, but that's totally up to you, as long as you will talk in the same way as the customer is talking with you, that you understand what we're talking about. So let's have a quick look in Netfabb. If I click on create base plate, I will just use the helix over here, that's no problem. I can see there's multiple options, for example, for the shape of the base plate.
Yeah.
Shape of the base plate, I can use shadow of parts, means if I am in a top view of a part of the platform, I can see just a part, and what's below the part, it's the shadow. I can select this, for example, and then I will just say I will use the hexagonal grid. There's also the possibility of selecting solid base grid, which is, well, I would say not recommended, because you will have a full platform printed without any holes, so really high force of separation, which is apparently what we don't want in order to not stress the reservoir.
Yes.
So I will just select the normal hexagonal one and use the standard settings. So this would be 0 in the standard settings, and perform this. So during this process, you can see on the bottom left where our picture now is, there is the calculation going on. And now we can see it created exactly from the shadow of the part a base grid. If I just use the top view, you will see nothing. That's just the shadow of the base plate. There is now two more options which you can play around with. So either use the outbox of the parts, which is changing not much. The outbox is always the rectangle, orange rectangle, which you see around your part. This is the outbox, which is then used as a frame for the base grid, or you use the entire build area, self-explanational. So we still keep the shadow of parts, but we use one more option, use only outer edge. If we use only the outer edge, it will just use, as it says, the outer edge of the shadow, and the inside will just be filled with the grid, because we are not taking care about this one. Sometimes you need it in order to remove it, for example, better off the platform. Sometimes you don't, depending on what you want to do. Just to see what's not a difference. Now it's not a ring anymore, it's a circle. Okay, let's go back to the slides. What is our recommendation? Well, as you have seen in Netfabb, we use always the hexagonal grid, as it's a little bit better than the rectangle one which is in there. Depending on what you're using as a support, maybe the rectangle one could be better for your purpose. So that's up to you. Recommendation: hexagonal grid, height 1 millimeter, offset 0. Cell size 1.5 millimeters and wall thickness 0.8 millimeters. These settings are also set as standard in Netfabb. If you do a new installation, you will have always these values at the beginning.
Correct.
In order to understand what's going to happen if you change something in there, let me just quickly mention the height of the grid. If you change it to a higher grid, so it's thicker, it's going to be more stable. You're going to use more material. And it's going to be harder to remove from the platform, as it's not that flexible anymore. If you lower it to a minimum, you will have a really thin grid. Well, it's easy to remove, but because of this, it can also be removed during the print process, depending on the separation forces. So it's really brittle then. The offset, nothing you should worry about right now. Only if you have special supports, maybe you need a grid which is wider than the part, or a grid which is a bit smaller than the part. The cell size itself, it's going down to how much area you're going to print and how much area is nothing being printed. As I mentioned before, the more area you're printing, the more or the higher is the separation force. So if you make the cell size smaller, you will print an area which is bigger than before. So in this case, separation force higher, lifetime of the reservoir will decrease. Same thing will happen for the wall thickness. If you make the wall thickness higher, you're printing a bigger area, more separation force, lifetime of the reservoir will decrease. So I think that's it for this one. Maybe let me just mention, if you make the cell size and the wall thickness, for example, you change the cell size to a bigger cell size, you can lose the connection to some supports. If you do the same for the wall thickness and make it smaller, so also the supports may lose connection, or the grid will get really sensitive and brittle and will also break during removal or during the print job.
Correct.
Okay, I think that's it for the base plate at the moment. So I will hand over to you, and we'll have a look at the settings.
So we just go into the last section in the work steps that are available in Netfabb. So these are the last two. After you've created the workspace, you have a magnetic platform activation button and a settings button. Now these are only visible when you have a workspace running at the moment, like we have. So creating the build, that's always going to be there by default, but that we will get to, because once you go through this, you go and create that build, and that's where you have that preview window where you can run through each layer and inspect if there's any islands or maybe any unexpected behavior that's happening in the printing process. We look at the magnetic platform, so let's quickly go over to Netfabb. I'll just zoom out a little bit. We already can see that the magnetic platform is activated in Netfabb. So this means that when we look from the front, that the model will make direct contact with the build platform. And there's no way for me to move it up. So I try and move it, but I can only move it sideways.
Yes, for example with the arrow.
Yes. Same with the green, I can only move it sideways, no up or down. But if I deactivate the magnetic platform, it allows me to move it up off of it or further down into the build platform. This is all dependent on your desire or your needs. The only thing to note in this instance is sometimes when a model is created in the designer software, it might not be perfectly flat. And then when you have the magnet platform active and you see, that looks like it's making perfect contact with the build platform, but in actual fact, there's just a small contact point with the build platform, which will be very obvious for you to spot once you see that preview window. Then we look at the settings. There's only a couple of things that we will cover here because it can get quite in-depth in a future webinar. But something specific that I wanted to talk about, so let's just go from the top perspective here. It just makes it a bit easier to see exactly what I mean. So there is, in the General tab, there's a void platform border. So this is referring to the line that's running on the outside of your build area. So if I increase this to maybe 2 mil and I just say OK, we will see how this then gets affected on here. And there you see the really thick red wall that runs along the outside. Now that's not a problem because you can still put your parts in that red area. You will just be prompted with a warning message making sure that you are aware of the placement of the parts. But if you have the parts outside of this black line, then you're outside of the build area, okay? And then these parts will not print, okay? So it's fine inside the red, but this only comes down to management. So if you have somebody who's not that familiar with Netfabb and you want to have some control over what they're doing, then this is a good tool to use. But by default, it's on 0.25, which is perfectly fine as well. The last thing that we wanted to talk about in the settings, as this goes down, so is in the information tab, and we are referring to the engine version. We already spoke about this yesterday, and we spoke a little bit about it today, because this is very important for this to be updated. So whenever you feel that something's not quite right, go and check online in our Knowledge Center. Go and verify if you have the latest engine installed on your Netfabb, because if you don't, this is where you can compare. So you can see this 431 is the latest one, and you can compare with what's available online, and so on and so forth. Okay? And lastly, yes, and that's...
I think that's it for the settings.
I think so, and that's part of the workflow when you're looking at the manual workflow.
Yes. So let's have a look at the automated workflow. Of course, the automated workflow is a little bit more handsome because you won't have to select the different workflows manually. For now, I can select, as Ignatius says, in here my workflows, and then click the buttons each by its own through, and then select whatever I wanted to do.
Yes.
There's a possibility to use the automated workflow, but therefore you need the R-shape STL file. So R-shape STL file is an output, for example, from CARES. You have to set it up in the material section, and you can then set it up as an export file as R-shape STL. This one will then select automatically the workflow which is corresponding and will guide you through it with some input you still have to take, but it's gonna select everything you mostly need automatically. So let's have a look at this. How to start the automated workflow. So in here, in the normal Netfabb, let's say in the machine environment of your machine, you can't select it directly. Why? Because you need a new environment. So the automated workflow has an own environment on itself. First step, always install your machine as we did it in the last webinar, normal installing. Then once the machine is set up, you can add another machine environment. So in here, it's the automated workflow. You will find it also if you add a machine, and in the add machine window, you go just to the corresponding area, selecting the automated workflow and add it to your machines.
Yeah.
So once you added it, you can just open also this environment. This environment, well, it looks kind of the same at the beginning as the normal environment. We will see it once it's loaded, but the engine, so the workflow and the work steps won't be visible as long as there's no file loaded. So in order to start this, we have got the import button at the top of it. Let's wait until Netfabb is responding again. And I prepared, for example, now one part. It's the gingiva, just as an example. You can use, of course, all the different indications which are available as a workflow in Netfabb.
Yeah.
So I now just click the top button, import. Now I can select, of course I will take Divos Codex Chaos as this is the R-shape STL format, and I will just use the gingiva. You see, .R-shape STL is filtered, so no other file can be selected in here in this environment. Once I select it, please have a look over here. It's selecting the workflow, the machine, the platform automatically. So I will now just say I don't want to start it automatically because I can see the material is wrong. So this is something we are gonna still improve for one of the following Netfabb updates, as the material will then be also selected automatically in order to the indication. Which means gingiva, only gingiva material. If there's no material added in the normal environment, it won't find the material in here and you have to add it in the normal environment. So, for example, I now already have the gingiva, so I can select it, and if I got multiple materials gingiva, it can still also say no, don't activate the automated one, just let me select my material first. So I will select, for example, the other gingiva material. Then I can still say, oh, now perform the complete automated workflow. So now it will run through these, well, in the gingiva it's not much work steps, and I can just confirm the settings by saying, yes, that's fine. You can see at the end we still have to ask you if the process is done in a good order. So if you're sure everything is fine, the design was good and it's placed well, you can click on yes, and the create build process will start. I will just click on no to have a closer look and see, okay, yes, it's placed flat on the platform, there's no gap in between, and it's in the middle of the area, exactly where I want it to be. So that's perfect, and I could create the build. Same for others, for other indications. As soon as you got R-shape STL, just load it and then run the automatic workflow. Confirm some settings if needed, and then you got a finished print job later. Okay, so I think that's it for now, and we can head to questions.
There was one particular question that came up in an earlier webinar.
Yes.
Regarding asking about which workflow you are selecting and how the settings are affecting other workflows.
Yeah, okay, so let me also just quickly show it. So I go back to the manual work environment. In this case, we still have got selected the manual workflow. So the question in the other webinar was, if I change in here, for example, the settings for my base plate, let's just use this one and say, well, I want a really thick one in here because I need this now for my manual workflow. I do some special parts.
Yes.
So I select this one and say, okay, perform it. Maybe I just need a small part. Let me drag and drop this box in here again. Drag and drop is, by the way, also working. You don't need to click the load parts if you use the drag and drop as usual.
Yes. Yes.
So I can just say create base plate, set the height to 3 millimeters because I want it, and say perform. So I now got a base plate. Base plate settings in this manual mode is now set to height of 3 millimeters. If I now switch to another, for example, just take the gingiva again, I can see there is no create base plate. So there is no effect on this workflow at all. If I now select another workflow where I know exactly that there is also a base plate being built, for example, a cast, I will have a look in the create base plate for a cast. Okay. That's maybe a bad example because in the cast we got a special grid which will be updated soon. So let's have a look for the crown. In this special time now, we use the crown workflow. In there, the create base plate button is as well as possible as before. If I select this one, I can see height is the same, but the offset is different. Why? We changed this one before in the other one, in the other webinar. So
Yes.
in order to let you know that these are completely non-dependent on each other, I will just create one which has 0.5 height and offset of 8 millimeters. And we'll go back to the manual as soon as this is created. And let's have a look if the manual was changing as well, or if it still has kept its old settings. So the previous one we changed already. So, and you see, it's still 3 and the offset 0. So non-dependent, I can change things in one workflow, the other workflow will still stay the same.
Yes. But please note that this is only applicable to the workflow and the work steps. If you're adjusting something in the settings of the workspace, it's going to affect it across all machines. These settings are, yes, a universal setup. So just be careful when you are changing something here that it will carry over into different workspaces. Okay.
So, Antonio's got another question. When using automated workflow, can Netfabb recognize dies or stumps and place them on the flat surface of the platform, so avoiding the holes?
Good question.
So at the moment, Netfabb is not able of doing this, but yes, we are aware of the situation and we're working on this, but I can't tell you when there's going to be the update, which is also making this one possible for us.
Yep.
Yes, we see a great benefit also in this one, and we're working on this. So Sean is asking if you can show how to manually add and subtract support. Well, we could show, yes. It's more a little bit going in detail, as we kept this a little bit more general, and the recommendation is to use the already generated or validated by us support scripts.
This is something that we will cover in a future webinar in greater detail. As this is just basics 2, we will go into greater detail later on with future webinars where we will be able to cover all the little nooks and crannies within Netfabb so that everyone's... But it's important that we don't skip any steps in this information process as to not have anybody drop behind too quickly or too early on.
So Ogushan is also asking something. What about support issue with automatic workflow? Does it come automatically as well? So let me think about this question.
Well, I think what he's referring to is when you're doing the automated workflow, it will prompt what the next step would be, okay? And then that's up to you to decide what you want to do in that step. So all the settings related to that, unless it's referring to the full auto. Yeah, so if you mean with your question that which supports are selected for each indication in the automated workflow, these are the pre-selected ones. So if you're gonna select a surgical guide, for example, R-Shape STL, the supports which will be executed are the surgical guide supports. So you won't execute the quick support in the workflow of the supports of the surgical guides. So, we still got a little bit time left. If you have got any further questions, just let us know.
Okay, so Antonio's asking, from all existing supports, what is the most reliable?
Trick question, Antonio. Again, this comes down to what material you're working with will be dependent on what type of support you would want to use. Because you can imagine, we print gingiva flat. The material is not that great to use with supports, so you can imagine that the support scripts that we use for surgical guides will not work for the gingiva. And this is where it comes down to getting into more detail with future webinars, where we will cover each indication and have recommended processes regarding the supports, placement, and all further details that might be required.
So I think the best answer on this one is then use the script which is predefined for the indication if we already have got a predefined one. Because we try to cover as much as designs with these support scripts. Of course, you won't use a surgical guide, for example, for a model, when you hollow a model and you need supports. And for example, also the partial framework. So we try to get these one really corresponding to the design. That's why there are different ones inside, because there's not really the one thing which is the most reliable one.
Unfortunately, yeah, that is the current situation. Yeah, great.
Okay, so do we have got anything more to say? Not yet. No questions at the moment. We can still wait a few seconds. Maybe somebody is still thinking about the question.
Yes, but please note that if there's something that you want to ask us, feel free to contact us directly at service, no, not at service, my apologies. The address is service@rapidshape.de, where we can further clarify anything that you might not think of right now, or that you might think about later on this week, or so on and so forth.
Yes.
Yeah. Because ultimately, the more you know, the more we can explore and be creative. It makes it, really gives us joy when we can see enthusiasm behind the machines.
Okay, I can see Joe has one more question. How do you import Co-Diagnostics file? So if you export in Co-Diagnostics also the R-Shape STL file, it's exactly the same way. Open the automated workflows, workflow, and then import the R-Shape STL file. Then the automated workflow will detect it's from Co-Diagnostics. It's then a surgical guide. It will select the surgical guide platform and so on. So it's also going to be automated. If you just got the export of the STL of Co-Diagnostics and not R-Shape STL, you can still import it in the normal workflow.
Yes. And use the guided workflow, basically.
So you're saying it's not an STL, it's a rapid shape file. So the R-Shape STL, yes. So R-Shape STL, you always load in the automated workflow. So if we just select the automated workflow, and here you can see, let's check it. So automated workflow, you can see there's also the button for Co-Diagnostics, same one as for CARES and DIVOS, as they are using the R-Shape STL for the automated workflow. Makes it easy to handle. So
all the properties basically get included into the import process, which just gives more information over to Netfabb, better handling. Indeed.
So I hope this was the right answer to your question. Perfect. So, if there are no questions anymore, then I think we can close up this webinar for today.
Yes.
Thank you very much that you joined in again. Oh, I can see. Is Netfabb going to offer cloud-based nesting? Well, maybe not. I don't know. I'm sorry.
Yes,
I can't tell you.
I don't think we've spoken about this as of yet.
Yes. So, no answer for now. I'm sorry.
Maybe in the future.
Yeah.
But thanks again for joining us. Really making a big difference for us on our side. And enjoy the rest of your day.
Yeah, and have a nice weekend. Stay tuned and stay three-dimensional.
Thank you.